Okay, hello. Here I want to make a short correction because in the previous video I wanted to extract the latest version available in the model based on project ID and model ID, and I had to ensure that the model actually has all the version data. But with the new policies of Speckle and the workspace structure, I no longer have access to all of the versions, but only 7 days back. So instead, I simply will extract the latest version using the built-in Python function getAttribute, and I will return the same type of data, which is string and the version ID. So let's go into the video. Okay, first I want to mention that I'm testing Rhino.Compute on a local host rather than in the cloud first. And if we later want to use Streamlit in the cloud, it will need to be able to reach Rhino.Compute also on the cloud as well. So, but for the goals of this video, I want to keep the local host. I will consider explaining the process of getting a request from Rhino.Compute in the following steps. First, I will get the latest version, and then we can see which packages are necessary for the process. We will also define the Grasshopper definition and the important Grasshopper setup. And lastly, I will establish the connection between the Rhino.Compute URL and the response received on the Streamlit page. So let's go ahead. Before I go to Grasshopper to show what is the connection with Rhino.Compute, I want to start from the previous video and note what we've added. So first, these are our new packages. We're going to need the base64 and the requests package. The first is to convert the Grasshopper definition from binary into a text file, string file, and we will be able to use JSON format for the work with Rhino.Compute. And the requests package is for the interaction with APIs and servers, as is the case with Rhino.Compute. Here the host remains the same, is the Speckle systems server. Grasshopper file path, we're gonna need our local file for now, and for Rhino.Compute URL also our local host to reach the server. As I mentioned in the beginning, we will gonna use fetch latest version, but with the function getAttribute from the selected model and its attribute preview URL, and we're gonna match this URL, the last symbols. This is going to be our version, and if this group matches, this is going to be our version ID. I will demonstrate how this is possible. One more thing to consider when exploring what lies behind the selected model is that in the main function we can use the vars function of the selected model as built-in utility of Python that can return the dictionary attribute of an object. So this object is selected model, and if I run this, and as we know, copy the project URL and extract the project ID. Now I can see that this dictionary has this attribute preview URL, and here at the end I can see the exact version ID. And if I check here in the versions, I can see after the @ sign, I can see this number as well. So this is the opportunity to check for the version ID this way. And now let's see more about the Rhino.Compute function. Let's take a look at this function. It takes three inputs: project URL, speckle token, and selected model ID. This here header says that the format is JSON, the expected format for Rhino.Compute, and project ID, full project URL that the server expects, the speckle server expects, with open Grasshopper file path in the beginning. So this is only for local Grasshopper definitions, as I said. If the Grasshopper definition is on GitHub, on the cloud, it could be different then, but this is not theme of this video. Rhino.Compute requires Grasshopper to be in JSON in string file, so I need this base 64 to encode the Grasshopper definition. And in the request data, the pointer is optional and the values are empty right now because this is only for test purposes. And here the request package sends to my local Rhino.Compute server, sends a request, and this is what the server expects. Okay, let's now go to the site of Grasshopper. So here I wanted to show actually how the scheme is functioning. So if I were to have in Grasshopper just the parameters, I have the structure. It is with its parametric geometry, it's prepared for Karamba 3D and it's calculated with the Karamba 3D package. And then the normal speckle setup, we can create object as data tree. We have our parameters, for example, which we want to see later on Streamlit page. I have my utilization value from the analysis, and this together I can build either the conventional sender for speckle without Rhino.Compute, or now I want to become a response from Rhino.Compute, actually, if this is connected, and I will need for it the synchronous sender for Rhino.Compute. This doesn't have the button send here, as it is here the case. Okay, this is so far for it. Now if I unplug this, I have only the requirements. So get number, this will be my number parameters. They're getting as before in the script, so I'm not changing anything here, but Karamba can't calculate right now. Here in the outputs, I will need for the sender, I will need actually the version of the model in speckle, which it is going to be changed, and to authenticate. So with this component, get with token, I will need the project URL and speckle token. This is only string, so get I think it was here, get string, and I can rename it as I want, but it is important that this name is exactly later as the name in the Python code for values, but I will not check this right now, maybe for later videos. This is the output that I need as text. This will be my new speckle URL with the model and project, and here there is something else. On the Grasshopper site is this hops component, which is, if I test it, is right now empty, but I can set a path. Sorry, I can show input path. You can go here, and for check purposes, okay, right now it needs time to calculate, and it will load exactly these inputs into the output, which are set for this exact Grasshopper definition. So this is like checking if everything is set up correctly for Rhino.Compute. Okay, a few moments later I already have the component built up, and this is the way how also this orange component has been created. For right now I'm gonna disable this because I already have this here. Let's check back with the Python code. So this remains, the structure of the main function remains as it was in my previous video, but only the parts with the button where I'm getting the version viewer from Speckle, and I've placed one more step, like step 5, check response from Rhino.Compute, where I will need this function, test Rhino.Compute, and if the result was successful, Streamlit is going to write this text, and if there was an error, then this text. Let's check it again. I will press this button. First, I'm getting my version on Speckle, and we see that is thinking again, so it waits for the Rhino.Compute response. Here we go, we have our status code, it shows 200, which is okay, and the response JSON file from the Grasshopper definition, and here it says that Rhino.Compute connection was successful. So basically we have our output name, and as set in Grasshopper, these whole parameters for the inputs. But still no values given, so this was only for the purposes to check if Rhino.Compute can connect with Streamlit via Python and Speckle. So I hope you enjoyed this video, and thank you for watching. Bye.